Hey guys, we've been talking about graphing or solving inequalities for several days now, and now we're going to get into graphing those inequalities. Okay, so we know that equations can be graphed, and they can look in three different ways. So the first way is it can look like y equals mx plus b, and that is always going to be a diagonal line. So a diagonal line. Okay. Our second way that the equation can be graphed is if you have x equals some number. Okay, so any number. And if that happens, you're going to have a vertical line. So a vertical line. Okay, your third type of way that equations can be graphed is when you have y equals a number. And when you have y equals a number, you'll always have a horizontal line. And so a horizontal line. Okay, so those are three different ways that equations can be graphed. Okay, so if you graph an inequality, what will it be looking like? Well, it's going to be similar to graphing an equation. So the first thing you want to do is first you solve for x or y. Okay, first you solve for x or y, and you'll have to look at the directions to decide which one of those you want to do. Okay, so first you solve for x or y, and number two, you want to graph the inequality. Okay, so graph the inequality next. And we want to graph it just like we would graph an equation, where we graph our y-intercept first and then apply our slope to that. Okay, so we'll do some examples of that. Okay, and there's two things that you need to think about when you are graphing a inequality. The first is if you're going to have a dashed or solid line, and then you need to decide where you're going to shade the picture. Okay, and the reason you have to shade is that an inequality represents many solutions. Okay, so let's talk about dashed or solid first. Okay, you're going to have a less than or a greater than sign. If you have one of those, a less than or a greater than sign, your line is going to be dashed. Okay, so if you have one of those inequalities, you're going to have a dashed line. Okay, so some examples of that would be as if your inequality was something like x is less than or x is greater than 4, or y is less than minus 11x plus 4. Okay, so if you have a less than or a greater than sign inequality, you'll have a dashed line. Now, if you have an inequality with less than or equal to or greater than or equal to, you'll have a solid line. Okay, so some examples of that would be if you had inequalities that were something like y is less than or equal to 8, or y is greater than or equal to 1/4 x minus 2. Okay, so as long as you have a less than or equal to or a greater than or equal to, you will have a solid line. Okay, so that is your dashed or solid line. Now you have to think about which way you're going to shade. So if you have an inequality that is less than or equal to, you'll shade all values less than the variable. Oops. Sorry, let's try to erase some of this. And of course, it doesn't want to. Okay, so shade all values less than the variable. Okay, so shade all values less than the variable. If you have an inequality that is greater than or equal to, you'll shade all values greater than the variable. Okay, so with your shading and with your deciding if it's a solid or dashed line, you really need to memorize these. It's not something that you want to have to look back on every time in your notes. You really, really need to memorize them. Okay, so let's go ahead and try some examples here, and we'll see what I'm talking about. All right, so let's go ahead and try this guy right here. So our first example is 1 is greater than or equal to y. Well, let's go ahead and rewrite that since that's not proper. Remember, we want our y up front and our 1 in the back. And since up here your inequality is facing the 1, let's keep it facing the 1. Okay, so let's go ahead and graph this. It says our y values are less than or equal to 1. So we know that we have a y value at 1. Okay, so let's go ahead and put a point. Let's make it in red. Okay, so there's our y value at 1. Okay, now our first thing we need to think about is if this is a dashed or a solid line. Well, let's look at our inequality. Okay, you have a less than or equal to inequality, so that would tell us that we need what type of line? Well, we need a solid line. Okay, I said that in our notes just a second ago. So let's just draw a solid horizontal line, because remember, y equals a number, you're going to have a horizontal line. Okay, all of this is said in your notes just a second ago. Okay, so now that we have our line, we can go ahead and decide where we want to shade. Well, it says that we want all of the y values that are less than or equal to that line. So where should we shade? We should shade all the values that are less than that line. Okay, so we would shade all the values that are underneath. So all of these ordered pairs would actually make this inequality true. Okay, so that's just our first example. We'll try a few more here. Okay, let's try this guy. You'll notice that it looks very similar to slope-intercept form. Y equals mx plus b. And remember, when we graphed these, we always did our y-intercept first, our b, and second, we applied our slope, or m. Okay, so on this one, our b is our positive 9, our slope is negative 4 over 1. So let's go ahead and graph this line here. So we have a positive 9 for our y-intercept, so let's go ahead and plot that point. Okay, so that'd be right about here. Okay, and then our slope in this occasion is negative 4 over 1. So from that y-intercept, we would want to go down 4, 1, 2, 3, 4, and over 1. And then we would draw that point. Okay, so after we've drawn those 2 points, we need to decide what type of line we should draw, a dashed or a solid one. Well, if you look at that inequality, you can see that it's a less than or equal to, and that would tell us that we need a solid line. So through here, we can go ahead and draw a solid line. Okay, now the last thing that we need to do is decide which way we need to shade. Well, it says that we need all the y values to be less than that line. Well, which way is less than? Well, a way you could think about it is go to one of your points, and from that go up 1 point and go down 1 point. Well, which one is actually less? Which one appears to be lower? Well, of course, the one below looks to be lower, so we're going to shade in that direction. Okay, so all of these ordered pairs that lie below the line here, or lie on the line, are actually ordered pairs that would make this inequality true. All right, let's try a couple more here, and then we will be done. All right, before we keep going here, I got a quick joke for you. What did the fish say when he swam into the wall? Think about it. Think about it. Damn. Ha 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 ha. You like it. All right, so on this problem, we want to go ahead and get it in proper form. So if we do that, we should have x is greater than 1. Okay, and now we got to go ahead and graph it. And the first thing we should think about is, where is x at 1? So if we think about it, on our x-axis, let's go ahead and plot a point right at 1. Okay, and what type of line should we draw? We know that it needs to be a vertical line, and that, so let's go ahead and decide that it needs to be a vertical line. And since we have an inequality without a line underneath it, we're going to have a dotted or shaded line, or dashed. Okay, so there's our dashed line, a vertical dashed line, and then we want to decide where we should shade. So we want all the x values that are greater than that line. Well, which way is greater? Well, in this case, of course, that would be to the right. Okay, so if we shaded all the values that were greater, we'd have all these ordered pair solutions over here. Okay, so we'll keep practicing these. Just make sure you're getting the notes down right now. Okay, this one, let's go ahead and have you try this one on your own, and then we will make sure that you're right. I'll come around and check it. If you want to have one as a reference, I would look at this one up here. All right, we got one more example to do, and then we will be done for the day. Okay, so we want to graph this. We know that our y-intercept is -5. We know that our slope is 2/3. So we want to graph our y-intercept first. So let's go down 5. So down 5 and plot our point here. So there's our point. And then we want to go our slope on from that y-intercept, which is 2/3. So we're going to go up 2 over 3 and draw another point. Okay, so since then you got to decide what type of line you're going to draw. And then if you look at your inequality, you have a less than, so you have an inequality without the line underneath it. So we need to go ahead and draw a line that has dashes. Okay, so we have a dashed line there. And then last but not least, we need to decide which way we're going to shade. And since our y values need to be greater than that line, we need to shade everything above that line. So let's go ahead and shade everything that is on top of that line. So all those ordered pairs would make this inequality a true statement. All right. Okay, so let's just go over a quick summary here. Okay, your dashed lines are going to be when you have inequalities that are greater than or less than. Your solid lines are going to be greater than or equal to or less than or equal to. Okay, so shading, you're going to shade above the line. Okay, so shade above the line for when your inequalities are greater than or equal to. And last but not least, you'll shade below the line for when inequalities are less than or equal to. Okay, so I know this has been a lot today, but we'll practice these at length. See ya.